So, hello everybody, I'm Milin. Sorry if you were expecting a redhead girl, but I'm going to explain a bit what I've been doing in my GameJam entry. So I wanted to, let's say, cheat on the rule, exploit them as best as possible. And the rule were stating that you can use as many UI elements as you want. So I decided to show that you can make games based only on UI element without using objects. So in this game, there are a few demos. Here I show basically the main principle. So you display sprites and you can modify their properties. So you can modify the scale, the position, you can add some text on it, like those menu items, I have text. The game engine is providing collision detection. And one core aspect is that you give a velocity to the sprite, and then the sprite will automatically update its position. So you can basically just map the velocity to your controller input, or you can set the velocity of an object so that it will follow some kind of time. So this video is showing a few glitches. Actually, I wanted to let them. It doesn't happen that often. But the thing is that Project Park is not giving you the way to make something perfect because you don't know the dimensions of the original UI element. They are not all the same dimension. And so if you want to compute the exact dimension of an element, you have to use a trick that I will explain later. So yeah, that's the most complicated game I've done so far using this system. So it's a simple arkanoid. So you can see here that basically I have 10 by 4 bricks, and I have the ball and the element and the paddle. So in theory, if I were using objects, I would be disqualified, right? So the thing is that since I'm not using objects, I have actually in my game, if you display the count of the object, I have one object which is the basic game engine cube, and maybe two if the menu is loaded. All the elements that I'm using are actually UI elements, and each UI element is contained inside a specific brain. So I'm using multi-brain a lot, but in a way that makes it easier. So basically a brain encapsulates a collection of variables, and one object can have as many brains as you want. I didn't check, there is probably some limit, but I don't know the limit. And you can actually access, you can sort your brains by the name of the channel and the name of the slot. So channel is like a category, and inside the channel you can put different slots. So I use that for the arkanoid. I'm basically keeping a two-dimensional array of brains, and each brick is actually encoded by one brain, as well as the paddle and the ball. So I noticed while recording the video that there was one element missing, is the button that allows you to exit the game and vote the game. So I will go through the process of adding this button with you so that you can see how easy it is to do. So the first thing is that I want a new UI type for this button. For example, in this example, I will use the grid icon in an attempt to encourage people to vote up the game. So you go to the asset manager, you copy the last line, then you check, so you get the icon that you want. So in this case, yeah, I will take this thumb up. Then you assign it a name. So this will be the asset property of your sprite. So when you set the asset property of your sprite to this string, it will draw the associated UI element. So once this is added to the asset manager, you can go in your game or in the cube that is handling your game. So in the menu, and you want to add a new sprite. So this is done with the add brain command. So you create a new variable, a brain variable. So in this case, I will name it menu4. So menu4 will be the button that allows me to exit. And you need to specify which slot you want to upload it. So basically, since the brain of the sprite is the same for every UI element, you need to assign every UI element to a different slot or a different channel. Then one of the problems is that all the properties of your sprite will be set the next frame, basically. So you need to wait until the sprite has the property ready to be true, and then you can start messing around with the properties of your sprite. So basically, I've done that using once ready, cumulative on all the sprite. Then I specify the properties of my sprite. So the text that I want to display, if I want any text, by default it contains an empty string. So you can display text. You have text offset, that is a vector, that allows you to specify which offset you want to apply to the center of the sprite for your text. Text color is the color of your text. And then the sprite itself has position, velocity. It has orientation property that is somehow the orientation in 3D, because we don't have the rotation of the sprite on the center point. So I'm actually faking the rotation of the sprite by using the scale. And it also has the position. So in this case, I was doing something smart for the other element. Here I will just display my button on the bottom right corner. So the fixed position of this bottom right corner will be 0.5 minus 0.5. So for those who don't know, the screen is basically, in Project Spark, is basically going from -1 to 1. So you have to specify all your position in this frame of going from -1 to 1 on both axes. What else? Okay, so here I have added my element. Now I want to now that I have added my new sprite, it will be displayed. I need to check for the collision between the cursor and the sprite. So I'm doing that by looping through all the elements, all the UI elements that I have added. So I forgot to increase the counter that is keeping track of the UI element that I've added. I'm using a for loop going through all the elements. Here I'm basically specifying that if this button is pressed, so I'm checking the number of the button that is pressed with the slot name. I want basically to exit the game and to trigger the game over screen. Then I will show you how actually the collision check is done. So the engine is providing you a way to check if two sprites are colliding, so doing the math for you of the intersection of the two bounding boxes. So basically it's here. So you can call a function by setting fx collider A and fx collider B, and then calling a specific page on this black cube, that is the entry point. So the specific page is called check collision. And this will basically take care of the math and to check if fx collider A and B are colliding, and it will set up this Boolean variable fx colliding to true in the case where they are colliding. So in case you wonder, you can actually call functions from other objects, and the variables that will be used by this page on the other object are actually the variables that are stored in the caller object. So that's the trick I'm using to avoid copy pasting this function all the time. Okay, and here I basically check the result, and if the result is true, I make the collided element to spin. So it has this, sprites have also this spinning property that make them turn on themselves. It's a speed basically. So this button is broken, and if we click on the thumbs up, it will end the game. Thank you! Okay, so most of the content of the video is over. I recorded a few attempts to explain some specific properties. You can watch them. They are not really in order, and they are not really done well. I think the rest of the video is not really done well either. But okay, feel free to watch the video or stop here and explore the code yourself. I think it's the best things to do if you want to learn. Ciao! So in this video, I will basically show how to add a new asset to the asset manager. So the asset manager is basically the structure that tells what the engine can do. So you just need to copy one of those lines and then to edit, to add from the gallery the asset that you want to draw. So you put that in the call to display, and then the main idea is that each asset is associated with a unique string that will be put into your sprite, so that the displayer knows what to draw depending on the string that is in the sprite. So here I added the string camera. I tried to use a convention that is, I store the names of the assets using a hashtag, and then when you want to use this string, you basically replace the asset property of your sprite by the string that you want to use. So in this case, it's the camera. So this tool that uses a ruler prop is basically a tool that helps you to measure the dimension of a sprite. Since Project Spark doesn't allow you to know exactly the original dimensions of UI element, I made this tool to basically know which proportion of the full screen they have. So when you basically load it with the sprite that you want, and then you stretch the sprite using the right stick until it covers the full screen. And when you've seen those numbers in the middle, they are basically the size of the sprite, the proportional size of the sprite. So if you want to know in terms of screen referential the size of your sprite, you basically divide 2, because the screen goes from -1 to 1, by the size that the tool has given you. And this will give you the size of the sprite with a scale of 1:1. And then you can, basically what I did is that you can store that in the original dimension of the sprite. And then when you modify the scale of the sprite, it basically recomputes every frame the real dimension, so the dimension that is scaled. And you access that. You set once the original dimension of your sprite, and then if you want to access, so during your game, you may actually modify the scale to make the sprite look bigger. If you want to know exactly the size that it's occupying on the screen, you can look at the dimension variable. It's a vector, and this variable contains the real size that the sprite is occupying on the screen, given the scale that you put. So basically, if a sprite was using 0.2 in its original size, and you set the scale of 2, it will be giving you